Programming Throwdown, episode 75. Arduino. Take it away, Patrick.
Welcome back to a non-interview Programming Throwdown. I
That's
really
right.
like the interview episodes. I always like talking to people. Well, I just like talking. I like talking to people. But, sometimes I was sitting down and picking my book of the show and my program show. I'm like, I kind of miss doing this. Like I've been too long without being able to talk about something I've read. So actually I like a lot. I had a lot of books and I had to pick one.
I actually did too. Yeah, I mean, I don't know if I mentioned this in the past episode, but Audible, they reached out to me in like Christmas, and I don't know if you got the same thing I did, but they said you could prepay for the year, and it was significantly cheaper.
Yeah, like almost like half price or something.
Yeah, that's right. It was half price, and I got all 12 credits up front.
Mm-hmm.
And I jumped on that, and and so I've been reading a ton of books. I picked one of them for book of the show, but yeah, we definitely have a backlog.
Yes, I also did. I did it a while before that, so I've actually had the 12 credits for a while. But
oh, nice.
Then you still get the access. This is off topic. And you get the access to the sales for the thing. And my commute is just long enough that like I just really enjoy listening to the books, and I really make it through them quite quickly. And so I have sort of a large catalog, but the 12 credits, like one per month, isn't really sufficient. So then they have sales where they run stuff for, $2 or $5 or buy one, get one free.
Oh, nice.
Or something. And so they'll email you like, oh, there's a sale going on. And I end up almost always picking up like a book or two from the sale just to supplement the fact of, having enough to listen to.
Nice. Very cool.
So, all right. But the first topic I want to talk about is something that I've actually talked with people about work about. When we interview people at work, this is a discussion that comes out. And so I thought it'd be interesting to sort of discuss it, hear what you have to say. I have some thoughts on it, I guess. And then generally, there won't be an authoritative answer here, but at least if people in the audience have this question, they'll have heard it. And that is, should programmers be expected to code in their free time? And I slightly changed it to working programmers because I think a lot of people listening who are students or not paid to program or doing a different job and doing programming on the side only do programming in their free time. But if your job is a software engineer or that you're being paid to do programming, is it an expectation that you should have a project on the side or something where you regularly do code outside of work to show your passion for programming? So I'll let you go first, Jason. So I teed it up for you, and let's see where you
all right.
It's
a tough question. So, okay, here's what I'll say just as a preface to this. I think that, your job is a kind of a gradient, right? So in other words, you kind of get what you put in and, hopefully, obviously it's not an absolute, but in general, you get what you put in and there isn't really like this binary, like, okay, you cross the threshold type thing. So, I mean, I would say, if people are doing some work on the side, that's part of kind of building your brand. And so I feel like it's going to help you in the same ways. There's tons of things that could help you. If you do, I don't know, speech coaching, it could help you, but when you say the word expected, anytime you use words like expected, it's kind of it's breaking down like that view I have of work where it's sort of this bank account and you contribute more or less and you get returns, and it's turning it into more like what's the bare minimum I have to do, there's basically two paths in life and how do I make sure I'm on the right path. And so I have kind of an issue with, I guess, the whole premise of the question. So I would say, no. I mean, you shouldn't really be expected to do anything. But it's also, I think it would help almost anybody. And so, I guess the question is, do you want to get more out of your career? And then the second question is, based on what you're doing now, is this the best, bang for your buck? In terms of like, from what you're not already doing to better your career, is this the next best thing? And I would say, actually, yeah, I mean, the thing about this that's nice is typically it's some project that's not, I mean, certainly it's not related to your work. That's why you're allowed to do it in your free time. You get full credit for it. It's much more resume building than the code at work, which you generally can't share. So yeah, I mean, I don't think anyone should be expected to do this, but I would say this would probably be on my top 10 list of things to do to, make your career go further. That's my 2 cents.
So before I say my piece, I'll ask it a different way. Would you, with not knowing anything else about a person's resume, or let's say we did a study where we gave you 2 resumes that happened to be identical, except one of them had work that they did on the side, in their free time, or pointed to a GitHub repo where they had some projects that they worked on actively, not like in the past, but they were actively working on projects. Like, how much more weight would you give that over the person who didn't have something, all else being equal?
Yeah, I mean, probably a lot, personally. I mean, again, if all else is equal, yeah, I mean, I would consider somebody who. So there's 2 parts of it. One part is, if the person has these side projects and they're actually popular, that there's a variety of skills that make that happen, right? I mean, if someone just took, tutorials off the internet and implemented them, and all of their projects have 0 stars, and it was just like an academic exercise, that's kind of different. But if someone has some projects that they built and they actually have a following, yeah, I mean, I would say that's pretty significant. Yeah.
Okay, so I think this is a difference because actually you and I differ on this. So you do programming outside of work, and I almost do no programming outside of work.
Mm-hmm.
And so I'll bias the other way, which is I actually,
sure.
And you are right, of course, with almost everything. You're safe in saying it depends.
Yeah, of course.
So if you have, a popular, like, wow, this is a true, almost equal to a job level of project that you maintain, right? Where I might interview you, even if you weren't a programmer, even if you weren't working at a company, even if you weren't a new graduate, just because of your work on that project. Of course, like, I think that's kind of, in my mind, a different category almost. But if you're just a person who has even a mildly popular or not at all popular, mildly popular here, I guess, is ambiguous. If you have something that I hadn't heard of, or that a quick Google search doesn't revel to me is like a very commonly used piece of software.
Like how many stars? Like maybe your project has, less than 100 stars or something.
Yeah. Then I basically don't count that at all. It's not even interesting to me. In fact, when people put their, and this is going to differ, which is why it's good that we're both presenting our opinions.
Sure.
But I almost never go to people's GitHub pages on their resumes. I'm just not interested.
Oh, yes. I'm totally the opposite. I mean, but I think to your point, if it doesn't have a fall, like, I don't know. I mean, I don't want to put a star number on it because it's much more like abstract than that.
People are going to be buying stars.
Yeah. But if it doesn't have, like, if there's never been a pull request, you're the only committer, it has 3 stars, then it's the same as nothing. But no, I mean, I look, and if it has some pull requests and there's some discussion and the person's making some decisions,
but I can suss out that. Oh, sorry, go ahead.
Oh no, I was gonna say, especially if it's big enough where you have sort of conflicting interests type thing, or you have to do some type of organizational work. And again, this is all things being equal. Here's one thing I will say just to finish my part is if I don't have that information, so let's say there's somebody who does nothing outside of work, well, then I would spend more time in the interview. I wouldn't really talk about their non-existent GitHub, but I would be spending that time talking to them about work situations, and presumably they would be able to fill in there.
Yeah, that's what I was going to say is basically that, which is I'm going to ask about that anyways to understand how does this person deal with conflicting interests? How do they manage their time? What are the kinds of things they like to do? So I'm going to ask those anyways. And as far as like the expectation, I mean, I think there is a belief, at least some blogs and whatever will say that, basically it's an expectation. If you're not passionate enough about programming to do it with like all your spare time, then like that's not the kind of person they're interested in hiring. And those people do exist. I mean, I'm not going to counter it, but I personally don't think that's true at all. I don't hold it as it is definitely not a negative at all for me if you don't have any external to your work projects. But that isn't to say, and I think Jason alluded to this in the beginning, although he might have said it slightly stronger than I did, which is if you do have something, it can be a benefit. If for nothing else, then for teaching you what it is you're not getting from work. And I think this is the difference is if you are currently, and I'm not saying good or bad, I'm just going to pick something. Like if you're currently doing, website, JavaScript, front end stuff, and you want to get into distributed data processing, but at work, you're literally just slammed with, layout of, the website, and you're not getting the education you need, it's going to be very difficult oftentimes to convince a team or a company to hire you for work in something you haven't proven yourself in. Doing external projects, even if they aren't popular, even if they don't go read your GitHub, will teach you the expertise you need to be able to talk confidently, at least at some level, in an interview. Now, you should still be honest that, hey, I've never, I only done this on my spare time, or only, examples, I've never done this at my company. Like, you should never be deceitful there, but you can still express a confidence that you understand what it is to do, distributed data processing or whatever. And I think in those ways, it is sometimes necessary as part of resume building or part of learning to do extracurricular programming.
Yeah, I guess the question is like, if we were to come up with a list of, someone comes to you and they say, I want to, improve my career. I'm a software engineer. I want to be software engineer level N+1 or something like that. Like, how would you prioritize, coding in your spare time versus other things? Like, what would be sort of your advice that would be better than this, right?
Yeah, it's difficult because, I think there are things you can do. For instance, I don't think it has to be programming. I think it could be reading, like reading about how, other people do stuff. Reading, it sounds like goofy, but, reading
that makes sense.
Reddit
Yeah, that's really
programming
good
or
advice.
Hacker News, reading books like, Coding Complete or whatever, something about
like how to negotiate a promotion.
Sure, something like that. Or even, not necessarily having a project in functional programming, but just trying to make it through a functional programming book. I think those kinds of things can also help. It doesn't have to be actual programming and debugging and building a project to completion.
Yeah, that makes sense. One thing we can both agree on is that if someone has an empty GitHub and they say they do no programming outside of work, that's not a disqualifier. So one of the things, there are jobs where, and I don't do a lot of UI stuff, so I'm probably going to kind of mess this up, but I've seen jobs where somebody hands you a picture of an app like that they drew in Photoshop, and they just say, look, I want the app to look like this. And for those kind of jobs, they're really interested in kind of throughput, right? And so if you're getting a job where like throughput is the most important thing, like lines of code per hour worked or something like that, then maybe someone could say, oh, I'm paying everyone's salary. This person who does all this stuff on the side, maybe I could get them to do 100 hours of work a week because, they have more energy. But those are not the jobs you want, right? So in other words, the jobs where they would expect their programmers to work in their free time are probably not the jobs that you want. So I wouldn't put this demand on yourself if you're a developer.
Well, that was something I was going to say, though. For me, I try to get jobs, interview, change teams, move within a company, whatever is necessary to try to get a job where I get, sounds bad, but get like the fulfillment I need about programming at work. So if I'm like, sense. Hey, if I'm really interested in embedded programming, then like I'm going to go join a team that's trying to do low level programming, or weigh like how much I care about that, because I want to be doing the thing at work that I'm really passionate about, and that sort of get that fulfillment. And then when I get home, I don't need to, I don't feel like, oh, I'm not doing the kind of work I'm interested in.
Yeah, that's another issue where we differ. Like if I had that mentality, I would be quitting every 3 months. I would be changing jobs. but that just comes down to like our, we have kind of different natures around that. But yeah, I think it's a really interesting question, and I think it's very hard to have a good answer. The one thing I would say is definitely don't put pressure on yourself if you don't code in your free time. I don't think that should be some kind of mandate or something.
And for what it's worth, I do try to convince people who have this attitude that like there should be extracurricular work. I do try to convince them that this is not necessarily true, because I mean there's also very personal reasons why it just might not be a good time for you to be doing things, right? If you just and it's not always, you're not bringing up as an excuse, but maybe you in your life recently struggled financially and had to work a second non-technical job, or you had a child, or you had an illness in your family you need to take care of. Maybe you yourself were ill. All of these things could be reasons why the person for a year or 2 or 3 years hasn't done this kind of stuff.
Yeah, and on the flip side, there could be someone who's done a lot of stuff in the free time because they are just not doing well in their job. And so you're kind of rewarding a bad situation there, right? So, yeah, I think with anything, there's a lot of ingredients that go into whether you're hiring or whether you're trying to improve your own career. And this is one of them. But yeah, anytime you see this like expectation, that's probably a red flag,
Well, on to news and links. My first one is a game programming tutorial using Lua, and I'm going to say it love, but if that's wrong, I'm sorry.
No, it's love. You're right.
Oh, okay.
I've actually used this before. It's a pretty good library.
Oh, okay. So Lua is a scripting language, and Love is a framework for making 2D games in Lua. And there's a couple of interesting things about this. So the link's in the show notes, but the game being made is called Byte Path. And it's partly interesting because the tutorial takes place in a series of GitHub issues.
Oh, interesting.
So the person made GitHub issues that describe all of the parts of the tutorial. It's also interesting because Lua has been one of those things that I don't even know for how many years has been on my list of I should really get acquainted with this and working with it. And I've always wanted to do some sort of simple or retro style 2D game in my giant list of things I never get to.
Same here.
One day I'll retire, but I'll actually just be super busy in retirement because I have to get through all this stuff I never did.
Yep.
And this is one of those. Anyways, it really struck a bone for me. It's I want to go do this, and just talking about programming in our spare time, and the fact that I don't do any of it means I didn't unfortunately follow this tutorial. But if you didn't see it when it was kind of making the rounds, check it out. So you've used Love before?
I ran some demos. I made a very simple thing with it, and it looked pretty cool.
Yeah. Have you done much with Lua before?
I have a long time ago. I actually wrote part of this thing called Diluculum, which you can look it up. I don't know if it even exists anymore, but it was basically a Lua C++ a binding API. And you could access C++ objects in Lua and vice versa. And it's kind of like, the Python API, like the Boost Python type thing, but for Lua.
Okay.
So I was really into Lua. This was, a long time ago. This was over 10 years ago. Honestly, as soon as I really found out about Python, I'd heard about Python, but as soon as I really got into Python, which was, as I said, about 10 years ago, Lua just died immediately for me. The Python C API is not as nice. It's harder to embed Python. But that kind of just slight mechanical challenge is not worth using any other scripting language or interpreter language. So I've been pretty heavy into Python. But I did think Lua was good when I was using it.
Nice.
So my news is it's actually a YouTube channel that I've been following for a while, but hadn't really talked about. It's pretty cool. It's called Charisma on Command. It's very popular. A lot of people listening to the show have probably seen it before. They had one that was really cool. It was how to make any story interesting. And in the past, I've always kind of felt like I don't know. I've always had sort of a what's the word? I've given kind of side eyes to people who over emotionalize things. Like when they're talking, they have too much inflection and things like that. It's always kind of a big turnoff, right? And I think it's still true. I mean, if you just overemphasize everything, people will, get kind of turned off. But this basically argues the opposite. It says, part of it because you kind of know what you're going to say, and you should watch a video. It goes into a variety of factors, but in general, your baseline is to underemphasize when you talk, and it's just a product of saying, for one, it's like you have to think before you talk in most settings. Most of us are doing that. And so you've already thought it through. You've already kind of played it out in your mind. And so now you're just reliving that you're just living out that prediction. And so just naturally when you talk, you're not using as much inflection as you want. And so it talks about that, a bunch of other things, but it really goes into detail on, instead of just, because you see a lot of these things where it's like, 3 interesting things you can say, and it's all about the content and how to strike up a conversation. They're usually so focused on content. This is just, you can't control the content. Like, you're going to say X. How do you make X interesting? And I thought it was pretty cool. And so in general, this Charisma on Command is amazing. I've been following it for a while. The videos are really useful, really interesting. But I thought this one really kind of struck a chord because it was not only interesting, but it's also something that I was kind of against. And then when I watched the video, it completely changed my mind. So I haven't really taken it into practice. I don't feel like I'm speaking more emphatically than I usually do. But I feel like it makes it's plausible now. Like it's something I would want to do. And so kind of mulling it over, but thought it was a fascinating video.
I feel like I don't know. I've never seen this video. I'm going to go watch this. This sounds intriguing.
You should check out a lot of, if you don't follow this guy, definitely go through some of his library. Maybe watch the top 5 most popular videos from him or something, but it's really, really interesting.
Interesting. I didn't realize that people would have like a bias against that though, but I guess that makes sense.
Well, yeah, I mean, there are those people you kind of tell, when somebody just really overemphasizes everything. Well, I guess it's kind of, I always kind of picture when someone overemphasizes right off the bat, I kind of just, in my head, I imagine that this person just hasn't been through a hard life. I mean, it's like not quite the right way to say it, but it's like if the first sentence is super dramatic, I'm just going to assume that it's not going to be that interesting.
But I guess there's okay. I need to watch the video. But I guess there's a difference between sensationalism, or like just over embellishing everything, or going into other details, and making something motivating or interesting.
Yeah, that's true too. Yeah, and they talk about kind of both of that.
Because it sounds like what you're saying is like you don't like people who open with just this like, I had the worst day ever. I found a single split end on one of my hairs, and you're just like, oh, exactly. Okay.
Yeah, and so the thing to be aware of is apparently when you talk kind of normally, completely unrehearsed, you're doing the opposite of that. And so by adding some more emphasis, you're really fixing just an inherent problem in the way human beings kind of think and speak on the fly. And so, at least, according to this video, you want to overemphasize a little bit to cancel out the like natural tendency to underemphasize.
But wait, but if everyone knows that people typically underemphasize, then they've already beefed it back up in their heads. So if you go around doing this, you're really just like exploiting people. Like you're just like, wow, that person just has more interesting stuff happen to them all the time.
Yeah, I mean, there's a question about in general, like, is charisma and persuasion, like, are these things exploitive? I mean, maybe. Yeah, I don't know. But it's good to know either way. It's sort of like if let's say you know how to, I don't know, choke somebody or something, right? I mean, knowing that is probably useful, maybe extremely rarely, but it doesn't mean you have to go around choking everybody. But having that skill is more useful than not having it, I suppose.
Well, maybe you're persuading me to. No, okay.
Yeah. Everyone's watching it right now. That's just I'm such a savant.
That's why our
No, I'm
listener
not.
count is dropping.
Yeah, exactly. By the second.
The next article I have is who killed the junior developer. This is an article written on Medium by a lady named Melissa, and she is saying that there a lot of, if you look at job requests that people have and postings out there, and it seems a lot of people are looking for senior engineers, and I always say I too would like a unicorn, because people ask for, I want someone with 10 years of experience in Node.js. Yeah. And it's like, wait, Node.js hasn't even been out 10 years. Or like,
yeah, right.
Well, maybe it has. No, I guess it hasn't. And just say stuff like that. Or I would like someone with 5 years of experience in embedded programming and 10 years of AI experience and 6 years of computer vision experience. And it's like,
right.
No way. Like, this person would have to, like, that's not a thing.
Yep.
But I think it goes a little further into just people don't want to hire. So there's that aspect, which isn't exactly what she's talking about. But instead, she talks a lot about, how companies want what they call sort of senior engineer, which there's a lot of debate about what senior engineer is. But they want someone who can hit the ground running, who doesn't have to be mentored or tutored. Like, they basically know how to get their job done. They're a craftsman at the job of computer programming. And how that, she feels that, and she brings into there some issues maybe with, how women versus men in the workplace handle the mentoring role or the mentee role. And I think that's interesting. But this fact of, companies want to hire senior engineers because they don't want to pay to train someone. They want to have someone who can come in and just start working right away. And not only do they not want to train someone, it's not just that they have to, wait for the junior developer to get as efficient as a senior developer, but they also typically have to spend senior developer engineers' times, bringing up junior developers. And the skill set of being a really good teacher or mentor isn't necessarily the same skill set as exactly what you need to get your job done. And that's not a revelationary thing that, there's a good solution here, but just kind of pointing out something that I've observed. So I sort of bring it up here, which is we kind of see this, or I see this happen quite often where, let's hire a senior person. I've been pushing on our team a lot for, let's look at more junior people, because, there are a lot of really talented junior people out there who are just looking for an opportunity. And, part of the interview process is making sure that you have the right opportunity for them. But I also believe that taking a junior engineer and helping them sort of grow into that senior engineer thing on your team helps them be really productive and really good at their role. And also, a very good fit for coming up in the culture and the situation and the team. If you bring in a senior person, they're going to, in some ways it's good because they're bringing a lot of experiences, but they're bringing on a certain amount of inertia and almost, you want to say baggage or whatever. They're bringing in a direction that they're used to heading and that they think things ought to be done. And sometimes that's good, but if you have enough of those on your team, adding more voices often can slow stuff down a little bit as you quibble more and digging up the why does your team use 4 spaces instead of 2 spaces for indentation or not tabs, right? Because this person is going to bring in, maybe rightfully so, as a senior engineer, they come in and they start to question things. But that's not always what you want.
Yeah, I think this article is super interesting. I like that point where, looking at it at a per hour basis, like we've talked about this in the past, but you have, certain times where you're kind of in the zone, and you have other times where you just can't be in the zone 8 hours a day, just banging out code. I mean, almost nobody can do that. And so you are either going to spend that time on, Twitter, or you're going to spend that time mentoring a junior engineer. So I feel like the idea of saying, it's taking away time and money from the company, I don't know if that really holds water.
No, but I think it is something, and we were talking about this unrelatedly before the show, but I think it is one of those things where you have to be careful about how to do well at your job. And if your company doesn't sort of see mentoring as something good, which is very rare, I feel that even if companies don't have an explicit mentoring program or a concept of that or bringing a new person up to speed, that I've almost always found by being a person who helps the new people and teaches them, like, has worked out well for me. It has been something that my managers end up respecting, that, their managers end up, realizing, and that the people on your team sort of know how that's an easier thing to deal with, because you sort of taught them your view of what the team culture is and how the code review process works. So it's sort of someone who ends up being, in my mind, almost more compatible with you going forward and having a good working relationship. So I've never had an issue where I felt like mentoring someone was, wasting time.
Yeah, definitely. I mean, even in, Silicon Valley, where, the average person only stays, was it 2.5 years or something at one job?
Yeah,
even then,
number.
It's still valuable. So, I mean, if you're at a company where the tenure is longer than that, then it gets even more valuable, right?
Yeah, and I've always appreciated when people senior to me, take time to mentor me and to help. I kind of wish it happened more. I really wish there was more of a culture of, teaching and learning, but yeah.
I think it's difficult. It's difficult at any company to really pull that off. You have to have sort of really good inter-company communication. And the thing is, it's not just having that communication, but it's preventing a few people from kind of monopolizing it. One of the things I've learned, not to go on too much of a tangent, is you want to have like really specialized channels of communication. Like we set up a machine learning noobs forum, and that worked really, really well. And so you might ask yourself, well, we had an engineering noobs forum, and noobs, for people who don't know, is like for newbies or new people. But in our case, it was literally just you ask a question about machine learning. Like you didn't have to be brand new to machine learning or anything. And we had engineering noobs. So the question is like, well, why didn't that just vacuum all the questions away from machine learning noobs, right? And the reality is, there's a few people or a few types of questions that kind of just dominated that forum, right? And then when you get even more broad to like, a forum with everybody who's in this office in a city or something, then it's just a couple of things will monopolize almost any forum, regardless of the size. And so getting the right channel, I think, will help the mentor thing a lot. But it's not trivial to get right. All right, the last news item is Detectron, which is pretty cool. So I shared a news a few months back of a GitHub repository that came with a nice tutorial for training like a mask RCNN network. And so the idea is like you'd give it some images and it would train, and it would be able to find the items on the page and stuff like that. This is similar. The cool thing about this is they already have some models already trained. So if what you're looking for, if you want to build a robot or something else that can kind of find things in images, as long as those things are from this set and you can search through the set of categories, I think there's something like 1 million categories, then you could just use one of these off-the-shelf models. You don't have to train it or anything. So if you wanted to write something to detect, dogs versus hot dogs or something like that, you could just use this off the shelf, and it would just work. I mean, it would also tell you other things, but you could just throw those away. But it would tell you, where the dogs are and stuff like that. So it's pretty cool. If you need to do any kind of image processing, if you want to build your own like paintball gun turret or something crazy, check out this Detectron. It's pretty neat.
It's time for Book of the Show.
It is Book of the Show. It's been so long. We're so excited. We're reuniting. My book of the show is Basic Economics by Thomas Sowell. And, I talked again a few months back about, I tried to build this economics type simulator, and I was using some pretty sophisticated machine learning, but I just couldn't really get it to work. And it turns out, after reading this book, I knew nothing about economics, or at least, I thought I knew stuff about economics, and I really didn't. This book is, I think it's like pretty standard reading for if you're in economics, like, undergraduate or something like that. The cool thing is, and it even talks about this in the very first like preamble of the book. It's the very first sentence is, you're not going to find any graphs, you're not going to find any equations. This is just about the principles of economics. It's written in a very like lay terms, so you don't have to be an economist or anything like that. It's really fascinating. It has some really in-depth case studies on planned economies. So for people who don't know, that's where the government or someone sets the prices. So in a sense, garbage, or maybe not garbage, but minimum wage jobs are, in a sense, a planned economy. Right. So if you work a job that's a minimum wage job, the government, as they change the minimum wage, they're changing how much money you're making. So that's a planned economy. Like you can't. Unless there's a massive shortage of your job and then it's not minimum wage anymore. But it talks all about these different planned economies, both like massive, large-scale planned economies that they had kind of decades ago in India and the Soviet Union, things like that. But also, local, in a microeconomic sense, like local planned economies, and basically like why they're all bad. So the book definitely has a slant towards pure laissez-faire free market economics. But, you obviously have to take that into account while you're reading it. But it talks all about these different economies, and it really explained things that I just didn't really understand. I was like, how does this thing cost so much? Why does this cost so little? Why is this happening? Why is that happening? It really it covers a lot of really interesting topical cases. And these are just core things that as a society, we get wrong over and over again. And it even talks about why we keep getting them wrong. It has to do with, it's just easy to convince a lot of people to do the wrong thing. And they'll love you for it. But it covers a lot of different scenarios. It's really, really interesting. One of the, just to explain like the simulation that I had, it didn't work for two reasons. One, actually, part of it was working. I didn't realize there's going to be some agents who are just going to fail. So part of having a good economy is that there needs to be sort of businesses that fail and businesses that succeed. There has to be sort of some risk, and the consequence of the risk is you go bankrupt. If no one's going bankrupt, then the economy's not really working. It means people can't really take any chances. And the other part of it is there needs to be a whole network of alternatives. So in my case, there were several businesses, but they were all doing the same thing in my little simulation. And so people couldn't say, oh, the price of, bread went up, I'm going to buy carrots instead. And so without alternatives, the economic system doesn't really make any sense. And there's I could talk for a whole hour. There's a whole bunch going on here, but you don't need to have a super strong background in economics. Definitely read it if these are things that are interesting. It's a pretty long book. I haven't got through it all, but even if you just read the first couple of chapters, it would be worth it.
Economics is always one of those things where I think a lot of people underestimate how good it is at explaining a lot of stuff that happens. But then there are sometimes people who overestimate, what economic theories can predict. And so it's one of those really... I've only ever studied economics at a very small level. And so there's a lot of things like you're explaining, these actually seem very fascinating. But then at some point, it's always difficult to map back, like you said, every time there's been a planned economy, it's failed. It's like, but, such statements always seem like, very difficult to make absolutely.
You're totally right.
You know what I mean?
Yep.
It feels like one of those, they say, this science of economics. I don't know if you would call it a science or not, but just like the study of economics always seems a little hard for me because it wants to make these absolutes, but you really can't because it's all about, at some level, all about humans. And it's very difficult to make absolute statements about human behavior.
Yeah. And even if you did, there's sort of a Heisenberg principle here, right? Like if you tell everyone, look, X is bad, then everyone will stop doing X. But then that will change the whole dynamics of the whole system. Like by virtue of everyone not doing X, maybe X becomes good, you know? So there's all sorts of weirdness going on.
Oh, you
there.
need game theory too. See, so you got to be an economics expert and game theory. And
yeah, I mean, it's all kind of tied together.
Yeah.
Yeah, so I would say, you know, the book, this person has a lot of strong opinions. You know, I definitely don't agree with all of it, but I learned an incredible amount.
So has it changed what you're going to vote for in the next election? No, it's okay. No, I'm just...
I have no idea. I could tell you that rent control doesn't work. That has been proven. And they just passed rent control in Mountain View, which is a city right next to where we live. This book talks all about all the places in the U.S. that have passed rent control and explicitly like what happens. And it just doesn't work. And it's not going to work here. But is it one of those things
where it can't work or it just hasn't worked?
I think I would say that it can't work. Basically, well, I'll tell you quickly what happens is people just start hedging the rent control, right? So they say, well, if I can lock in a good rent, then, you know, I have a kid, my kid's 10 years old, 8 years from now he'll be 18. Let me just get an apartment and rent it at, you know, whatever the controlled price is now. And that way, if the price goes up, then my son can live in this apartment when he's of age, right? And so you end up with just massive vacancy, which is what you have in San Francisco and New York City, actually. And he just said, you know, every time they've done rent control, you end up with huge vacancy rates. Now, there's a question of like, is vacancy rate the right metric for success? You know, I don't know.
Well, but I mean, couldn't you? But it's always one of the things where people feel they're different. So, you know, Mountain View just enacts rent control, but we're different, or we're doing it this time, or we introduced this tiny, slight difference where, you know, basically if it's vacant, then, you know, you lose the rent control or something, right? Like you could always try a slight variation on it, or it be different this time. If that makes sense. I don't know.
Yeah, I know what you're saying. Yeah, I mean, maybe, you know, I mean, obviously the more the more restrictive you make the allocation of rent control, the closer it's going to get to a freer market. So there's some gradient there, but yeah, I mean, who knows? It's a good question.
I mean, this is the, what is his name? Oh man, now this is going to bother me. Nassim Taleb, the Black Swan, I think it's a Black Swan is where he talks about this, is the, you know, the turkey befriends the farmer. I've probably told this story before. I don't know. It's actually his story.
I've never heard it.
Oh, okay. The turkey's on the farm, and, you know, every day the sort of turkey sees the farmer, and, you know, the farmer feeds him. And so the turkey goes, wow, this farmer's my friend. And, you know, oh, this farmer's my friend. And this goes on for, you know, like a year. And the, you know, turkey's completely convinced that this farmer intends me no harm, that he's my friend. And then one day it happens to be, you know, the day before Thanksgiving, and the farmer is not the friend of the turkey. Yeah. And it's like, you know, everything's the same. And you can come up with, you know, hey, look, every time we've done this, it shows that the farmer is my friend. And then one day it just isn't.
Yeah, I see your point.
And so, like, you can say, oh, I have a model, I have an understanding, I have my Bayesian prior, until none of it works. You know, I hope it's hit that book. And the reason why I say I think it is because basically that's the black swan. Nobody believed black swans existed because everyone had only ever seen white swans.
Right.
So
right.
There are only white swans in the world. The only color a swan can be white. And then someone finds a black swan, and they're like, "Oh, okay, black swans exist."
Yeah, exactly. Yeah, I mean, it's a good question. I mean, I think, but to your point, that's why economic systems are constantly failing. So that's another thing is, you know, there's just, I mean, we've seen that basically every 7 years there's some big crash, but then even then there's these micro failures in the economy, and sometimes they have to sort of, like they talk about in this book like 1/3 of Venezuela's oil was like just messed up. Like I mean, the oil was fine, but just the pricing just got jacked up, and a bunch of like like World Trade Organization people had to basically just step in and start doing manual things. Like this person was, guaranteed to buy this oil, and then they just like canceled the guarantee without any penalty. They basically had to like do this arbitration among all these people manually because the system had just failed. So yeah.
Well, my book is nothing so serious. It's a science fiction book, and I recommend a lot of hard sci-fi, or, sci-fi that's like, I guess you would call it deep, long form,
Sure.
very interested in kind of the world building stuff or whatever. This one is not like that at all. So this is Fuzzy Nation by John Scalzi. I've recommended books of his before. And this is actually a retelling of a older book, just sort of like updated and made newer. I haven't read that older book, so I don't know anything about it, other than in the sort of preface they discussed that, this is a retelling of a older sci-fi story for modern times. And it's a story about a person who is some amount of time into the future, on a different planet, some interesting things happening. But it sort of pivots around the interactions of the people and the companies and the planet and some of the native species of the planet, and a question about just like how, and when I say a question, it's not like some deep thought-provoking, I really wonder. It's just a lighthearted story about kind of like what does it mean to be sentient or alive, or how should we treat things as humans. And it's not asking, it's just a play on that, I should say, rather than questioning it. And so I'd recommend it. It's a very easy read, or at least I found it to be very lighthearted and easy. And since I listened to it, not read it, I guess, easy read and easy listen. Mm-hmm. You didn't have to like sort of, what was happening there? I really have to focus. You can just sort of listen. It's kind of fun and goofy and humorous at times. So that's Fuzzy Nation by John Scalzi.
Cool. Yeah, I also listened to the Basic Economics, or still listening to it.
Oh, okay.
And we're listening to it on Audible.
Yeah, is that cheating? I feel like I just say read, but it's because...
I think it's the right thing to do.
Okay.
Yeah, I think read is fine.
It's just too confusing.
Yeah, we should ask the folks at Audible. So, if you want to listen to these books and tell people you read them, you can check out Audible. You go to audibletrial.com/programming throwdown, and we have a link to that in the show notes. And if you go through us, I think you get your first book free. Is that right?
Yes.
First month is free. And we also get a thank you from Audible, which is really great for us and helps keep the server lights on the servers. We're also, if you already have Audible or you want to donate in a different way, we have Patreon. We have a custom Patreon RSS, by the way. I haven't ever mentioned this on the show. I've talked about it a little bit. I mean, it's on the Patreon page, but the downloads are faster. The uptime is a little bit better. So if you go on Patreon and give, I think the minimum is $1, you can get access to the really fast RSS feed and get the downloads a little bit quicker.
And we just an update. I guess we could do it later, but for the people, we had said everyone who was Patreon at the New Year was going to get a little Programming Throwdown badge thing. I don't know what you call it, like a laser cut thing. I'm staring at a giant stack of them sitting on my kitchen table.
Nice.
So
we did a couple of trial runs.
Yeah, I was going to say, we ran into some manufacturing difficulties. And so Jason and I had to iterate this more than I anticipated we were going to have to. I thought, this will be easy. It'll be great. And it turns out this is why Kickstarters are hard. And this wasn't even a Kickstarter. And people aren't even, anyways.
Yeah, I mean, nobody's really written in saying, hey, where's my... where's my thing? And so
yes, thank you for your patience.
Thank you a lot for that. Definitely mass producing things is hard. Props to Cafe Press for drop shipping our t-shirts. They have the system, but for us it's like once a year thing, so we don't have like a real system in place, but we're gonna get it done. We went through some manufacturing issues, but the latest set has been solid.
Yes.
And so
when we say manufacturing issues,
soon.
what we mean is like when Jason makes the design and I laser cut them and then I mail them to him, and working out that like how thick the plastic should be and how do we mail it so that it doesn't crack on the so that you guys don't get just like bits of plastic instead of a nice Programming Throwdown logo. So
exactly.
It's been fun. Well, we should talk about it at some point and write it up. Anyways, it is kind of interesting.
I have all the pictures. We should make like a little kind of blog type post about it.
Yeah, but I do have what is this? This is about 25% of them or more sitting on my kitchen counter. So
very cool.
I'll be sending them your way shortly.
Very cool.
So tool of the show. Oh, sorry.
My tool of the show is hyper.js. So I was doing some work on Arduino, which we'll talk about later. And I wanted to have a good Windows setup. And I was also doing some Raspberry Pi work and stuff like that. And I have the Ubuntu Bash for Windows thing. I don't know really what you call it, but the thing where it's like Ubuntu is running inside of Windows, but it still runs in the Windows command line app, which is not that great. And I found this hyper.js. It's really, really cool. It's basically it's all implemented in JavaScript. It's built on Electron. Which is what a lot of apps nowadays are built in, so they can be kind of cross-platform. And it's just a super, super nice terminal. It has tabs, has multiple windows, all the things you kind of expect from like a really nice terminal. And the thing is, you can use this on anything. So kind of if you learn the shortcuts and how it works and stuff like that, that knowledge will carry over to any machine. You could be on Mac, you could be on Windows. Be on Linux. Hyper.js works on everything. It's super, super cool. I'm actually thinking about trying to make it my de facto terminal. I use iTerm right now at work, and I'm using this at home. And on a couple of the computers at home, I'm still running the like GNOME terminal. I'm thinking about just taking the plunge and just doing Hyper.js for everything. But so far, I'm really liking it.
I know that I think I recall when this was first came out or gained popularity, and people were sort of complaining that, look how long it takes from when you type or punch a button on your keyboard to when the letter appears on the screen. And I know they have the same complaints about Atom, which is an Electron-based text editor, about being slow and problematic.
Yeah, that's actually fixed. So,
yeah, I was going to say, they did fix it. But before it was a legitimate complaint.
Yeah, I saw the GitHub issues, like kind of complaints about it. Like some of the GitHub issues are still open, but basically, yeah, they just did a bunch of work on the back. I mean, I don't know specific. I know one of the things they did is they wrote their own terminal emulator instead of, I guess there's this thing called HTerm that's built into Google Chrome, and that was slow. They replaced it with something else. But yeah, those you're gonna see those issues on blogs and things like that. But I haven't found that to be a problem anymore. So
well, yeah, what I was gonna say is like I've used Atom, and there are faster things. I've not tried this, but I think a lot of it just depends. So I wouldn't be dissuaded off of stuff just because of bad blog posts. Like anything, you got to try it yourself.
Yeah, that's true too. I mean, I didn't try it when it was slower. I mean, maybe it's still slow. I just don't care.
That's what I was going to say, is maybe this stuff is slow, and I just run on fast enough computers that it doesn't bother me.
Yeah.
Like I tend to run on computers that are quite well spec'd, I guess, for stuff like text editing. But I can imagine, I mean, it's a legitimate complaint. Like there is no reason a text editor has to take that much RAM. But for most people, it probably just doesn't matter.
Yeah, I mean, I will say, Hyper.js, it's all JavaScript and HTML. So, in other words, if you press L on the keyboard, it's actually updating some HTML component. And so, that's going to be way slower than any other terminal. But, I mean, it's completely imperceptible. I mean, things that would bother me would be if I ran a command that generated, let's say, effectively an infinite amount of output and I had to kill it and that command wouldn't die. That would be really frustrating. But I tested this out. I did like a find slash where it's just going to list every single file on my hard drive. And I killed it, instantly. So, I haven't had any issues.
Cool. My tool of the show, based on the previous manufacturing defect thing, is that I have a laser cutter. It is a very low-end cutter from China called the K40, and normally you have to install, which is why I actually didn't buy it even sooner than I did end up buying, which I've really liked it and it's worked well for me, although there are tons of caveats around it. and stories of people's stuff catching on fire. So always keep my fire extinguisher near.
Oh my God.
And never leave it unattended. Well, it turns out if you're, cutting stuff with a laser and like it makes fumes and those fumes could ignite, like, yeah, of course, like you need to watch what you're doing and have proper fume extraction and air blowing to disperse the fumes and keep an eye on it.
Wow.
Okay, that was really terrifying sounding.
Patrick is sacrificing his life for our Patreon subscribers.
And be careful what you cut, just if you're going to get a laser cutter, because some stuff you cut will release toxic gases. But there are laser safe materials. Anyways, Long story short, the software that you're supposed to use to run this is like ranges from, is there any way this could possibly work, to I'm definitely getting a virus from installing this. And so I was really not wanting to do that. And you have to sort of plug in a USB hardware dongle to run what some people sort of say is like a counterfeit version of some software or a pirated version of some software. And then there's a plug-in and it's just like, ooh, I really don't want to be messing with this.
Wait, why is this so hard? Like you basically have to just point the laser using a couple of stepper motors and then turn it on, right?
Correct. But these are made for people who use some specific software package to, I think it's actually said that this is for making sort of stamps based on your name in Chinese.
Okay.
But they've just found out they're generally kind of cool and useful for hobbyists, and they're really cheap to make. And so they've been sort of retasked, and this is whatever company that sells them, this is their solution, and it's just not very good.
Got it.
So instead, one option is you could replace the controller board that controls the stepper motors to just take G code like a 3D printer would be. And there's lots of people who do that. And I've considered doing that because you can actually get more control over it.
Sure. But
what you could also do is somebody basically sniffed the protocol and figured out what this definitely virus-laden software was doing with keyloggers. They basically figured out what protocol it was doing, and they wrote a very simple UI where my workflow is basically Jason kind of makes the pattern, and I think maybe you use Illustrator or Inkscape, I don't know. And then I sort of edit it up in Inkscape to be, sort of what I need, and then you import it into the software K40 Whisperer. So the name of the laser cutter is K40, and this guy made this free software and has a source code for it, K40 Whisperer, that will allow you to control the laser and cut your designs without having to install horrible, unknowable software on it. And it's been awesome. I've really liked it. And it's crazy what people do and then just sort of like release for free. I'm always sort of...
Yeah, this is nuts.
I'm always sort of, shocked that... I guess this guy is doing programming in his free time because he's not...
I was going to say, would you hire him?
I mean, I don't know. I've not looked at the software, but I am appreciative that he's doing the work.
Yeah, that makes sense.
Although it's an interesting thing. I was thinking about this because I think it's a quite difficult problem. So we were talking about 3D printers, the slicers.
Right.
Most of the slicers are sort of free, and so I guess you get what you pay for at some level. But they do a lot of random things that seems like they should be able to do better. And it is a really tricky problem, but, these are people doing this in their free time, and a lot of them are probably, I'd assume, probably self-taught. And the complexity of the things they're doing is actually quite astonishing given those constraints. But it's like, wow, it really seems like you ought to be doing better, because there's often where you'll just get these movements where the print head or the laser cutter will just sort of like cut down in the bottom left and then move all the way up to the top right and do a little more cutting and then move all the way back again. And it's like, it really seems like you should have been able to run some optimization and not do that.
I think you found your next side project.
Oh, no. I keep thinking that. I'm like, no, I bet this problem is way harder than I think.
Yeah.
So I won't fool myself. But K40 Whisper, if you're in the very small minority of people listening who has a laser cutter, and that laser cutter happens to be this thing and happens to be one of the ones compatible, I would definitely check this out. But you probably already know if you are. But anyways, shout out to these guys. This is amazing.
Yeah, very cool. All right. So we are going to try our best to cover Arduino. There's a lot to talk about. I mean, we could go all day about Maker whatever, but yeah, we'll talk about Arduino kind of specifically. And if you have any questions about any Maker stuff, just post on Facebook or anything like that.
Yeah, so Arduino, I think a lot of people have probably heard about it, and Jason sort of said the kind of maker movement or making things. I mean, Arduino, I remember when it, was sort of first coming out and people were, wow, what is this overpriced thing that is coming out of Italy and is, underpowered, draws too much, current, and is sort of laughable. And that was sort of the people who did embedded programming, which is something I was involved in at the time, which is why I was sort of peripherally aware of this. And in a lot of ways, they were right. Objectively, the Arduino shouldn't have worked. It was made by people who kind of didn't know, at least from reports that I can understand, they were students at the time. They kind of didn't know what they were doing, and they made a bunch of sort of, what would you call, I guess, like rookie mistakes in designing the PCB for Arduino, the sort of power adapters they've used. And then in what is, a great show of it kind of often doesn't matter, it's not the best solution that wins all the time. And I guess Arduino hasn't won in that it's not by any means the most commonly shipped microcontroller, but it almost, in my estimation, probably single-handedly created the behemoth of using microcontrollers for this maker and hobbyist movement that it is today.
Yeah, I think a big part of it is they're pretty well connected with the maker community, but they're also very accessible. And not only are they making this board, but they're also writing all these tutorials. They have a bunch of assets. There's a whole class of, here's a Bluetooth chip that's designed for the Arduino, which means that there's a library, which we'll get to later, that you can link in to make use of this chip. And so it's kind of like all of that extra work probably matters a lot more than, do you have the best design?
Yeah, and I don't think anyone had attempted to think that was a market before. That,
Yeah.
There was BASIC stamps. I don't know if you know about these BASIC stamps. Anyways, where you could write code in BASIC and use microcontrollers, and I knew about these or whatever. But they were always like quite expensive, even compared to these. And just never caught on because, like you said, there was never this enough of a network of tutorials and people using it and easy to use as a priority kind of thing. They just never seemed to catch on. And then also one of the things that it was one of the very early things, and it's probably not the first by any means, but it's one of the things I remember as being kind of an example of the open hardware and open software, where, before people would say, well, here, I'll open the hardware, but I'll keep my, drivers and firmware closed. Or here's open source software, but I am not going to tell you the exact details of what I, put on the chips and in the, in the board. But the Arduino stuff is open, both the IDE, the software that goes on the sort of so-called firmware that goes on the chips, and the boards themselves are all completely open. Yeah,
that's right. There's no reason why someone couldn't make a perfect replica of an Arduino and sell it themselves. And we'll talk about that.
Yeah. Yep. But I mean, I think the difference is that you just can't use the name. But yeah, so the Arduino really is this, as Jason was already sort of talking about, more than just the board. It's the board, the communities, the libraries, and we'll probably accidentally use when we use the term Arduino, for me, I really mean all of those things together. Right. Yeah. It isn't just any one of them. So the first thing to talk about is sort of this Arduino IDE. It's really not an amazing IDE. It's relatively simple. In fact, I think Arduino project used it from, I believe it's the processing project or something, where they already had this IDE and they sort of reskinned it, ported it. There's not really much to write home about, but what's interesting there is that because the Arduino is often the first embedded hardware and unless you've done phone development is common now, I guess is pretty similar, where you do cross-compiling, where you have an IDE, and unlike Visual Studio or GCC, where often you compile code and then run it on the computer that did the compiling, you're compiling code on your computer and then sending it to a different kind of computer. In this case, the Arduino, which is, we'll talk about in a minute, an AVR. And so you're doing this cross-compiling. So, that's sort of one interesting nuance. And the second thing is that you then need to do the quote unquote programming, not the write your program programming, but the putting your program on a board called programming. And so one of the things that the IDE is responsible for doing is making sure that you're doing the correct protocol for programming the board you have plugged in and sending that code over. And then also doing the remote debugging where you can sort of, if your program goes awry, you can debug it from that IDE. But it does so over the USB connection to the board because the program isn't running locally. Your IDE is running locally, but the actual code is running on the Arduino.
Right. Yeah, exactly. I've used the Arduino IDE for this robot arm I'm building, and I thought it was pretty reasonable. I mean, as Patrick said, it's nothing to write home about, but it seemed you got the job done. It has some basic functionality. It'll tell you if you have errors, things like that.
So one of the things that is interesting about the Arduino is that it is just really C and C++ that you use to do the programming in the Arduino IDE. I guess I should say that in actuality, you can run the same compiler that the Arduino IDE is running under the hood, and you can do everything yourself. And you could write in any language that has a backend that supports that, which I think there's probably LLVM support for the AVR backends. So you can probably write in almost any front-end language you want. So, probably C, C++, Java, I don't know, any whatever LLVM supports, which is basically everything.
Sure.
But what is interesting about the C and C++ that the Arduino it uses is this thing called wiring, which is really just a set of, they call it a core, the core. It's a set of functions for doing things like turning a pin from a low voltage to a high voltage, which could turn on an LED, for instance, or reading a value off of a pin so that you could, for instance, tell what voltage is being applied to that pin, which you could, control from a variable resistor. And those are really just function calls, but you write them, they're C function calls, but you write them in the sort of skeleton app that the Arduino IDE provides you. And you really don't even know that you're writing C for the most part. You're not doing the things we traditionally associate with C, or that I would associate with embedded programming, like using, bit masking to set register values. That's all hidden away from you in a set of C function calls that you could think of as the Arduino API, or as this wiring language, or what they call kind of the core.
Yeah, so you're operating at this layer where you're just saying, hey, is the pin 7 high? Like, is there voltage coming across pin 7? And it just says yes or no. So it's a Boolean function, but under the hood, they're probably doing all sorts of wizardry. Like, I guess they're checking the voltage that's above some threshold or something like that.
Yeah, I mean, what they're doing is they're reading and writing what they call registers, which are memory mapped ports that give you use and access as if they were bits of RAM, but they're not. They're physical circuits, and but you're basically just scripting it, but you're scripting it in C. So this very accessible maker thing is really written in C, which is somewhat not what you would expect, I guess. That would be what caught on.
Isn't there another language though, like Scratch or something, or am I just making that up? But I thought the Arduino came with like a language that they were pushing, and the C was like an optional thing.
I mean, this wiring is this set of functions. I don't know that it's any other language than just C.
Oh, okay.
So there is something called a sketch, and a sketch.
Oh, that's what it is. Sketch.
Sketch just means a program, though. But different than if you sat down and wrote a program for your computer, you would, start it in C. You would start with, int main, and then I'm not going to say it out loud because it gets hard, but the type signature necessary for main. And then you would write your code in there. But one of the things that a sketch does is it really just says, hey, I need you to provide two functions for me. The first is setup, where you do your setup. And then a function called loop, which is I'm going to call it in a big loop for you. And I want the thing that you want to do repeatedly, you should put in this loop function. And then what it does is the sketch has an external file that has that main, and it calls the underlying platform, the board setup. It configures all of the clock speeds and everything in this init function. Then it just calls your setup function and then just calls your loop function in a basically a while true loop. So there's a while true loop and it just calls your loop function. And so a sketch is a file which I think they have it .ino, a .ino file or whatever, but that's really just a bit of C code that they embed into this other, framework, and they just call your setup function and call your loop function. And you are just writing C in there, but you often call these other functions that do all of the, heavy hardware lifting for you.
Yeah, that makes sense.
When you kind of know what's going on, it's surprisingly kind of simple, but it is rather clever to do it this way because it really makes all of the explanation you have to do to someone about why main has a bunch of parameters that come in and why is void main considered bad. Like, why are you supposed to have int main?
Exit codes and all that.
Yeah, no one wants to explain that stuff. Like, it's actually not really, I mean, it is important, but it isn't the most important thing to a beginner.
Yeah, the other thing that's really cool is there's a list of example sketches, and they're all one file. Yep. Because all of the main and everything else has been done for you, and there's so many other libraries, et cetera, et cetera. So most of the time, you can do something simple in just one file, and so there's sketches that just one of them turns a stepper motor, like 360 degrees clockwise and 360 degrees anti-clockwise, and just keeps doing that in a loop. Another one has like a little joystick, and you wire up a joystick to the correct pins, you run this example sketch, and then it'll just tell you the x-axis of the joystick. Like, it'll just print it to the screen. So if you move the joystick to the left, you start getting negative numbers. You move it to the right, you start getting positive numbers. And so these sketches, these example sketches are just like right there in the IDE. You just go in File, Example, boom, you get a list of like 30 examples. They all require some hardware, which we'll get to later. There's packages that have all of the example hardware. But yeah, just having that resource is super, super useful.
Yeah, I mean, oftentimes this has become my thing with picking a Linux distribution is I just want a Linux distribution that's most likely to have the answers to the question before I ask it.
Yep.
And that sounds really dumb, but I guess I've somewhat optimized my life around this for several things now. Where if I know I'm getting into a hobbyist thing, I kind of want to pick something that I know is going to have answers before I have a problem, because otherwise I'm going to waste all my time trying to get them. And Arduino is really successful there, as Jason said. Like, they've already given you examples on how to do a lot of things you're going to want to do. Read a variable resistor value, a knob, move a motor, turn on an LED. You're not going to have to, post a question on Stack Overflow to figure out how to do that.
Right, and some things have specifications. Like, for example, there's an LCD panel where you can wire up, I think it's like 4 or even 8 pins it takes. I think it takes 4 pins. But with those 4 pins, there's an entire protocol that's saying, okay, set these pins at these times, and, with just those 4 pins, you're going to display a whole bunch of stuff on this LED. Like you could fill the whole LED full of characters, right? LCD, sorry. And generally that would be kind of a huge pain. Like, it's some custom protocol. It's probably based on timing and all sorts of stuff. But Arduino just has a library for that protocol. So you import this Arduino library, and then you just say, hey, I want the LCD to display JSON, and that's it. You don't have to think about the protocol. It does all the work of sending the right thing at the right time to just make the LCD display whatever you want.
And the thing that Arduino does, one of the things Arduino does really good is instead of exposing you the 20 parameters that protocol has, it just picks at reasonable default. and doesn't bother you with the details. And you probably can get at the details if you want them. But traditionally, you would have been exposed to, a giant function setup where if there was already a library, which there probably wouldn't have been, you would have had to go to the data sheet and figure it out yourself. And even if you did, you would have had to answer 20 questions you didn't know how to answer about timing, how fast you wanted to refresh, and what amount of power do you want it to draw.
Yeah, exactly. I mean, I plugged in an LCD panel with Arduino, and it's just put in a string and boom, it's rendered. So Arduino's, and maybe it's because Arduino knows the hardware. Maybe that's part of it. So there's only so many. There's a Arduino Uno. There's the Due. There's the Mega. There's only a handful of different Arduino chipsets or boards. So they probably just handle these cases for you, and they know what the right defaults are.
Well, yeah. So we'll talk a little about the processor. Originally, the first ones were targeting 8-bit Atmel AVR chips, which are quite cheap chips. And the fact that they were 8-bit doesn't mean you could only do 8-bit math. It just means the processor is natively 8 bits. And so doing anything more than 8 bits takes multiple instructions. Won't get off into that right now. But they're surprisingly sort of low amount of resources and low amount of speed. But people still manage to do a lot with them. Because you're not doing things like rendering full graphics to a display. And so you can do, kind of a lot with them, more than you would think. But now there are, as Jason was saying, there's a whole bunch. And they have moved on to other different kinds of processors. The other thing to point out is that although the Arduino line itself is actually still, although much bigger than it was, still pretty small, there isn't anything from stopping you from implementing this core for other processors. So people have taken, before Arduino had a Wi-Fi option, took chips that had Wi-Fi on it and ported it. They've taken faster processors and ported the core to it, so you can write Arduino sketches for other boards. But one of the things that was pretty distinctive, and other boards have adopted them as well, that wasn't just this easy to use interface over the processor, but they also did this certain board shape where they had these female headers facing up, which are headers you could plug into, and they exposed almost all of the pins on these headers that face up, so that you could, you could just poke a wire down into them to use, which is when Jason says he hooks up a screen. You may just be as simple as literally like plugging a wire into that that header. And then they had what's called shields, which like sit down on top of that in this form factor and plug right in and, expose all the proper pins that you're going to have on this shield. This extension board, this add-on is going to be exposed right to there. And that was something they did that maybe other people had done that before, but that was the first time I had seen something that did that. And it was really quite clever.
Yeah, I'd never seen anything like it before. The other thing, too, is you might say, like, oh, these chips are so underpowered, et cetera, et cetera. Let me just get a Raspberry Pi. The Raspberry Pi is like $20, right? The thing about it is, the OS is, as Patrick was saying, the OS is super, super lightweight. And on top of that, the OS is...
Wait, there is no OS, to be clear, in the Arduino.
Well, what is it called then? I guess firmware? I guess the...
it's just the program.
Yeah, okay. That's
sure,
fair.
you could call it firmware. That's fair. Yeah.
Yeah. So, Raspberry Pi, let's say you miswire something and you want to, shut down the Raspberry Pi, plug in some different discretes and turn it back on. Like, it has a boot up sequence. You could corrupt the file system, right, on the SD card, right? It's not really designed for you to be constantly plugging and unplugging things. It's going to take a long time to boot up, etc. The Arduino, it just starts within, 2 seconds or something. There's no disk, like no file system that you're going to corrupt or anything like that. And it has, the Raspberry Pi has a lot of the same pins, but, for development, it's going to be a very painful experience to develop on the Pi.
Yeah, as Jason pointed out, I mean, the Raspberry Pi processor is way more powerful than what's on the Arduino, but they're not really meant to do the same thing.
Right.
Yeah, so you're not meant to be rendering Windows in a full Linux distro. They actually do have an Arduino now that I think has a full Linux distribution on it, which is sort of confusing. But for the most part, weird. That's not what people use the Arduinos for. It's more like Jason said, just you would have it to toggle some pins, turn on some LEDs, move some motors, and doing that from Linux is, to me, actually slightly awkward.
Yeah. I mean, and if you needed the horsepower to run like a camera or something like that, you could always take something that works on the Arduino and, as long as you're using the same pins on the Raspberry Pi or do some mapping or something like that. But you don't want to be doing the development on a Pi. That'd be bad.
Yep. And so one of the things about all the different hardware, as Jason already mentioned, is that they have these really awesome libraries that you can download and use. So there's a bunch of included ones for things like moving stepper motors. But then there's all sorts of other ones for like, I want to know the barometric pressure outside. I want to know the temperature from this chip. I want to record sounds. All sorts of little chips that go into cell phones and cars and airplanes and you name it, accelerometers, whatever. These kind of devices get made by the millions and millions, and people mount them on, adapter boards, little PCB boards to work with Arduino, and then provide these libraries so that they just become really quite easy to use.
Yeah, I mean, one thing that kind of shocked me when I first got started with Arduino a few months back is the fact that, if you need drivers for everything, right? I mean, like even if you get, let's say hypothetically, you get a USB adapter, like a USB, I think USB is just 4 pins, right? So you could, take a USB device and you could plug it into 4 pins in your Arduino. But at the end of the day, like you need a driver, like with Linux or with Windows, you plug in a USB joystick and there's like a generic, HID driver that covers almost any joystick, right? With Arduino, I mean, that might exist also for Arduino. I haven't actually looked about joysticks, but it's a completely different universe. And so things which are very simple, when you have, I guess, just to use Patrick's words, when you have an operating system, become very hard in Arduino as well. So,
but that is the way it works. So, this is actually great education, and there is a lot of job opportunity for this, which is things like, you'll hear things like I2C, SPI, serial. These are like communications protocols that chips use to talk to each other. And unless you're doing some very specific work in Linux, you're unlikely to ever know that, the exact protocol that's running over USB that allows your joystick to work, or that your phone processor uses to talk to the camera to control it. But if you're on Arduino, you're going to be thinking about those things. And there are a lot of libraries to help you out. But you're going to learn about how those things work and what it means. Like, what are the trade-offs for running those protocols faster or slower or over long distances, and about what happens when different devices require different voltages to work at.
Yeah, I still haven't figured that one out.
But so we talked a little bit about external hardware, but the Arduino also has some internal hardware. So it has some voltage regulators, so providing different voltages on its output pins. It does have some analog to digital converters, which are what allow you to read external voltages. So if you hooked up a microphone or a light sensor, or like we were talking about, a potentiometer, a variable resistor that you were using to use as like a knob to control, the position of something. Those all ultimately produce what's called an analog voltage. It's just a voltage that moves smoothly between two set values. So it might go 0 to 5 volts, and it could be just any value in between. But of course, the Arduino can't represent the infinite number of values between 0 and 5. So it has to make them into discrete steps, and it's called sampling. It samples them and makes them into the discrete set. So if you say 0 to 5, and I'm going to use 8 bits, so I have 256 values to represent between 0 and 5. And so you cut up the range 0 to 5 into 256 buckets. And then you see which bucket the voltage currently falls in. That's what an analog to digital converter does. And the Arduino has some of these internally so that you can use them, and libraries for making it really easy, where you just say, I think it's just analog read, and it just gives you a 0 to 255 answer for which bucket the voltage is currently in.
Yep.
Then you can do, it can do analog out, which I believe the base Arduinos don't actually have digital to analog converters, which would give you this. So instead they do what's called pulse width modulation, which I won't get into. It's actually really complicated, but basically it makes a square wave that is on for a certain percentage of the cycle, and then smooths that out with a capacitor so that you get a voltage that's roughly, corresponding that. So you could do analog right, or if you want to move a servo motor, which uses PWM directly, that would be how you actually move it to a certain angle.
That's right. So I have, the robot arm is just done with a bunch of servos. And if you, as Patrick said, if you give, let's say, 3/4 of the voltage, then it's going to move 3/4 of the way. If 0 is, all the way to the left, and you give it 3/4 of the total voltage, it'll move, 3/4 of the way from left to right. And you can control it. And Arduino abstracts all of this away to where you literally just give it the degree.
Oh, really? The angle?
I want it,
nice.
Yeah, exactly. You just say, I want it to go to angle, 45 degrees, and it just figures it all out for you.
That's really nice. Yeah. And then we talked a little bit about shields. So, have you used any shields, Jason?
I haven't. There is a servo shield. So there's, not to get into too much detail about this, but there's stepper motors and servos. Basically, servos can only go, I think, at most 270 degrees. So they can't, spin around in a circle or anything like that. But the servos are self-aware. So you could tell a servo, go to degree 23, and it'll just go there, right?
It's a closed loop. Closed loop.
Yeah, and when it starts, it knows what degree it's at and everything. Well, it's more than just closed loop, right? Because stepper motor, I believe, is also closed loop. No? Well, the stepper motor, you give it a difference. You say, I want it to take 2 steps, and then it will make sure that it takes those 2 steps.
Oh, this is getting really off into pedantic stuff. It's not important. But
okay,
actually, the stepper motor, if you're holding the motor, or it's over torqued, and you tell it to move and it can't, it won't actually know if it succeeded or failed.
Oh,
which is why if you ever have your 3D printer hit the print and skip where it misaligns, that's what happens. It lost steps. It hit something and couldn't move, but it didn't know it couldn't move.
Oh,
the servo is closed up. It will continue to fight you, and if you hold it, it will just keep fighting until it gets to the position you told it to.
Interesting. Okay. So, but anyways, the stepper motor takes, I don't know why the stepper motor takes so many more pins. It's probably just whatever the different technology is. The stepper motor takes 2 pins, and the servo only takes 1. And so there's a shield you can buy which gives you just a lot more pins. So you can control, 8 stepper motors or something like that. But yeah, I haven't had a need to do that since I'm only using servos mostly.
But there's shields for everything. So you can imagine, a printed circuit board, a PCB, is like a piece of fiberglass with metal traces and the circuitry sitting on it. And that's what the Arduino board itself is. But then you can basically get another board that plugs into the Arduino board that is shaped often similar to the Arduino board. And you could have a display on it. You could have, like Jason was saying, a whole bunch of connections for servos and stuff. You could have it be able to control lots and lots of LEDs. There's all sorts of crazy ones. There's ones with batteries on them, so you can actually run the Arduino without it being plugged in.
Oh, cool.
Yeah, so you can find all sorts of shields. And these shields are just a common shape, and a set of libraries is normally what's expected that allow you to plug in to the Arduino and add functionality, add hardware that it didn't start out with.
Yeah, that makes sense. So I think we've mentioned GPIO, but we haven't said what it is. GPIO just means general purpose input output. And so what that means is you can plug something like a servo into one of these pins and send signal out to that servo. You could also plug in something like a joystick that's sending data into the Arduino, and the same pin can do either or.
Yeah, so sometimes a pin could be an input and sometimes a pin could be an output. And it can switch back and forth. It's programmable.
Right.
Yep.
So as far as things you plug into the Arduino, there's a ton of stuff. There's as you said, motors, LCD panels, there's things that sense water. So you can have a little thing which is like, it looks kind of like a long circuit board, but what it's actually doing is it's telling you the water level. So it's just, I guess, I'm not quite sure from a physics standpoint how it works, but you would stick this, and it will just tell you like how much of this board is full with water. So where the water line is. There's all sorts of crazy stuff. Cameras. There's like depth sensors, things like that.
But ultimately, everyone wants to make a robot. Is that right? Like, I feel that's the...
Yeah, everyone at some point wants, some type of motor or some set of motors, and then some type of input, whether it's like a camera or some kind of like a stop sensor or something like that. And all of that is totally doable with Arduino. And the libraries make it super, super easy to use. So there's like a depth sensor that's compatible with Arduino, which typically when they say compatible with Arduino, what they mean is that they're providing some type of software. The Arduino IDE also has a sort of repository of libraries. So someone makes a depth sensor, they can upload the depth sensor library to the Arduino cloud, I guess. And so you'd put the part number and you'd get their library. And the libraries are really where the magic is, because like I've been getting kind of more into it. I really thought that I was going to have to learn a lot more than I actually did. And it's because the libraries are just hiding all of the complexity from me.
Yeah, I think Arduino is really awesome. It isn't something where you would ever get a job using an Arduino. Maybe there are, but it would be an exception.
Yeah, highly unlikely.
Very unlikely. But it does introduce you into a world. It's a bridge, because to go from not knowing how to program to doing embedded programming is a really big jump. There's a lot of things you have to pick up. And so what the Arduino has really done, or has at least brought into the mainstream, is the ability to use a little bit of programming and a little bit of understanding of electronics and still do really cool things.
Yeah, exactly. And so there's a lot of kits and starter packages. I'll say the one I got, I think my heuristic was basically a lot of Amazon reviews. So I didn't do a ton of research, but they're also not very expensive. So, which is really nice. So I got the Elegoo Ultimate Arduino kit from Amazon. But basically it came with Elegoo is a company that manufactures electrical components, and so they made following the spec, that open source hardware specification, they made their own Arduino, and so you get this kit. It's I would say it's maybe like 16 or 18 inches by about 12 inches. It's kind of like this, but it's about 2 or 3 inches high, so it's relatively thin. This box comes with like a bunch of resistors, voltage regulators, all sorts of sensors, motors, servos, stepper motors, all this stuff, the Arduino. And then you can go on their website, or you can, using the CD that's included. I literally didn't have a CD reader, but I got everything off their website, a PDF manual. And it's a really long manual. You don't have to go through all of it. But it's just a ton of different things you can do with Arduino. So for example, I want to build this robot arm. So I went straight to the servo section And the cool thing, it has pictures. So it has a sort of schematic of what it should look like once you've plugged in the servo and everything. And then it has like actual real life pictures of what it should look like. So if you have trouble reading the schematic, you can see the picture and say, oh, like I'm doing this wrong or what have you. The other thing, I've yet to, blow anything up. I did blow up a stepper motor controller. That was completely my fault. It's kind of a long story. I basically touched it on this this metal box, and it shorted out. So yeah, just quick PSA: don't have a lot of metal things around when you have just bare PCBs.
And when you say blow up, I assume you mean you let the magic smoke inside the chip that makes it work come out.
Yeah,
Not
exactly.
actually caused an explosion.
Oh no, it was just a tiny pop, and some smoke came out, and that stepper motor controller was only 80 cents, so it wasn't a big loss. But yeah, nothing, I was in no danger or anything. But yeah, so I went through this kit, and it was fascinating. I mean, I learned so much by going through the kit. They also explain things like how to read a resistor. So the resistor has certain colored bands, and there's a certain procedure where you can look at those bands and then know the level of resistance. So it talks about it touches a lot of different areas, and you end up with real tangible things that you could take pictures of, show your friends, stuff like that. So check it out.
All right.
That's pretty much.
We must have had a lot of pent up discussion, because this has become a very long episode.
Yeah. There's a lot going on. It's been a long time, but thanks again for everyone for your support. We're definitely going to get the Christmas gifts out ASAP. So probably in the next few weeks or a month or so.
Yep.
Definitely, if you've built anything with Arduino, send us some pictures. We'll post it on Facebook, and we've gotten a lot more Facebook followers. We're up to something like 6,000. So thank you for that. We'll post to all 6,000 people a picture of your Arduino experiment if you send it to us. So yeah.
And then everyone will star your GitHub repository.
That's right. And then you can get the raise you've always wanted based on your GitHub repository.
All right. Till next time.
See you later.
The intro music is Axo by Binar Pilot. Programming Throwdown is distributed under a Creative Commons Attribution Share Alike 2.0 license. You're free to share, copy, distribute, transmit the work, to remix, adapt the work, but you must provide attribution to Patrick and I, and share alike in kind.